All right, let's talk about something we all deal with, probably more than we'd like to admit: traffic. Specifically, we're going to look at the traffic lights that pretty much run our lives on the road. And we're going to see how a new kind of hybrid AI system is about to give them a serious, much needed brain upgrade. I mean, we've all been there, right? You pull up to a red light. You're the only car there. You look left, you look right. Not a soul on the cross street. And yet, you just sit there and wait. And you start to wonder, is this thing broken? Does it hate me? Well, I've got good news and bad news. The good news, it's not a conspiracy. The light isn't out to get you. The bad news, the technology running most of these intersections is, well, it's just old. It's outdated. But that's exactly what's getting a major overhaul. So let's unpack the problem, and then we'll get to the really cool solution. To really get why this new system is such a breakthrough, we gotta start at the beginning. We need to figure out why our traffic systems so often feel completely disconnected from what's actually happening on the road. It really all starts with the original, old-school method of traffic control. And believe it or not, this is still super common today. I'm talking about the simple, unthinking timer. So this is the most basic setup imaginable. Engineers will look at historical data, stuff like the average number of cars that show up at 5 p.m. on a Tuesday, and they program a fixed schedule based on that. The light just follows a rigid rulebook: 30 seconds of green, 30 seconds of red, over and over. It doesn't matter if there's a 10-car pileup or a totally empty street. And here is where you see just how silly that can be. The plan is rigid, but reality, it's messy. So, when one street is backed up for blocks and the other one is a ghost town, the system doesn't care. It just sticks to the program, which means you get that wasted green time and, of course, a whole lot of frustrated drivers. Now, obviously, engineers knew this wasn't ideal, so that led to the next logical step in this evolution: let's give the traffic lights some eyes. These upgraded systems, you've probably heard of them as SCOOT or SCATs, use detectors in the road, little loops that can tell when a car is there. If traffic gets heavy, they can extend the green light. And this is a huge improvement, but it's got a couple of major flaws. First, it's purely reactive. It sees a car and reacts. It can't plan ahead. And second, if one of those sensors breaks or the traffic model it's using is a little off, the whole system can get confused and actually make things worse. So, if just reacting to what's happening right now isn't good enough, what's the next big idea? Well, it's simple. You have to learn to predict the future. And that is exactly where this new AI system comes into play. And this, right here, this is the fundamental shift in thinking. It's a total game changer. We're moving away from a system that just responds to the present moment to one that actually anticipates what's about to happen next. This lets it make way smarter, more strategic decisions for everybody. Okay, so how in the world does it predict the future? Well, the first part of the secret sauce is something called a Kalman filter. Now, the easiest way to think about this is like a super smart weather forecaster, but for traffic. It takes in all this messy, noisy data from sensors that might not be perfectly accurate, and it cleans it up. It filters out the noise to give a clear, reliable prediction of where traffic is going to be in the next few minutes. And then you have part two of this dynamic duo, reinforcement learning, or RL. So if the Kalman filter is the forecaster, RL is the grand master chess player. It runs millions and millions of traffic simulations, and it learns from trial and error. It gets a little reward when it makes a decision that reduces wait times, and it gets a little penalty when it causes a jam. Over time, it literally teaches itself the best possible strategy for the entire intersection, not just the easiest move for one line of cars. Okay, that all sounds incredible, but does it actually work in the real world? Let's get to the fun part. Let's look at the data and see what happened when they put this system to the test. First up, a 35% reduction in the average delay. Just let that sink in. That's more than a third of the time you spend just sitting at a red light. Poof, gone. And it's not just about waiting less, it's about moving more. The system was able to get 15% more cars through the exact same intersection in the same amount of time. It's just more efficient. Now this one is huge. Remember how those older systems could get thrown off by a broken sensor? Well, thanks to that Kalman filter we just talked about, this new system is twice as resilient. When a sensor fails, it doesn't just give up. It can work around the problem and keep things flowing smoothly. And this chart just puts it all into perspective so clearly. Look at this. With the old school timers, the average wait was around 80 seconds. Not great. The reactive systems with detectors, they brought it down to a better but still long 55 seconds. But this new hybrid AI system, it slashes that all the way down to just 40 seconds. We're talking about cutting the original wait time in half. That is a real, measurable improvement you'd feel every single day. So, what's the big takeaway here? We've seen this evolution, right? From rigid timers to reactive sensors, and now to a predictive intelligence that can actually learn and adapt on its own. This table really sums up the whole journey perfectly. Fixed time systems were just too rigid for the real world. The adaptive systems that came next were better, but they were too reactive and, frankly, too fragile. This new Kalman RL hybrid, the one that predicts and learns, it's not just a small step up. It's setting a completely new standard for what we should expect from our cities. And that really brings us to a final, much bigger question. Because this isn't just about traffic, is it? We are proving that we can build infrastructure that anticipates what we need and adapts to us in real time. The technology is here. So if we can teach a simple traffic light to learn and predict, you have to ask, what other everyday frustration should we teach our cities to solve next?